Hi, friends. Imagine you are inside a state of the art robotics innovation lab. This lab builds hundreds of delivery robots, cleaning robots, security robots, and medical assistant robots. Ever wondered what really happens before a robot comes to life? It all starts with a blueprint, a full design sheet that decides everything the robot can and cannot do. And here's something interesting. Not every part is free for anyone to touch. Some components stay locked away, accessible only to the engineers who know exactly what they are doing. Look closer and you'd notice patterns. Cleaning bots, delivery bots, security bots, they all behave in familiar ways. Why? Because each robot family follows shared rules that keep them predictable. This entire ecosystem mirrors TypeScript's object oriented system. Today, we'll walk through how the lab works while understanding TypeScript's most powerful features. So let's look at classes. So what are classes in TypeScript? Classes you can think of as the blueprint of every robot. In a robotic lab, nothing starts without a blueprint. Every robot begins as a design file that defines what it must have and what it can do. That's exactly what a class in TypeScript is, a blueprint for creating objects. So let me just create a class for a robot. So that is class robot. Um, Now the robot will have a name, which will be of type string. Then it will have a constructor, which will take the name string. And we will say this dot name is equal to the name. We will add a greet function, which will say console.log hello, I am dollar this dot name. Yeah. So this is my robot class done. Let's create a robot now. Constant robot one, which will be of type robot. Let's give him a name as Atlas. Is the space in here, which will be of type Atlas. And let's call the function greet. Yeah. Let me just run this code. Sorry. Let me just run this code. Yes. So what I've done here is I've created a blueprint for a robot. So every robot will have a name as string. Then this function, the constructor, will assign that particular name, whatever I have provided, to that particular robot. And I have defined a greet function. So what this greet function does is it just console logs saying, hello, I am, in this case, I've passed Atlas. So it will say, hello, I'm Atlas. So this is a simple blueprint for a robot.
And then what happens if the constructor part is removed in this code?
So for every class, we require a constructor. So if we remove the constructor, it will throw some errors because see, for every class, we require constructor so that let's say like in this case only, I want to assign the name to the robot. So that is done by this constructor. So it kind of creates the object for you. It creates and initializes whatever value. So like the name, then let's say I want to also define what that particular robot can do. So whether it's a cleaning robot, whether it's a security robot. So those functions also I can define in this constructor. So constructor is basically it creates the object for you. Yeah. So let's move ahead. So let's look at the next, that is access modifiers. So what are access modifiers in TypeScript? Those you can think of like the security levels of the lab. So our lab maintains strict control. So public is anyone can access. Private are internal mechanisms only. And protected are accessible only inside the lab or specialized sub labs. Let's see how the robot blueprint enforces this security. So this my class robot. Let's say this name is public since anyone can see the name of the robot. Now let's say the battery level that I will keep as private since only the robot will see what the battery level is. That will be a number. Let's say it is 100. Yes. And let's keep it protected serial number. That will be of type string. This can be accessed only by the engineers who know what they're doing. So in my constructor name, and I'll take the serial number as well, which is of type string. Yeah, and this dot serial number. Yes, correct. Now let's initialize. Also, let's show the battery this time. So public show status will be instead of battery level is this, and I will also copy this over here. Hello, I am this. My battery level is this. Okay, yeah. Now over here, my name is Atlas, and I will also pass this. Yes, and I will call r1 dot show status. Yeah, now this greet from here. Yeah, let me do the TC. Yes. So as you can see over here, I've passed an additional parameter that is the serial number for this particular robot. So here I can see it greets me with hello, I'm Atlas, and my battery level is 100%. So in this particular class, what I've done is I've kept the name as public. So anyone can see the name of this robot. Now the battery level of this particular robot can be accessed only by this robot. No one else can access this particular variable, that is the battery level variable. The protected variable, that is the serial number, can be accessed by only this class and not by anyone else. So in my show status, what I can do is I can do this dot battery level. Since it is private only to this class. Any function within this class can access this particular variable, that is the battery level. In a robotics lab, many robots share similarities. So all cleaning robots share some abilities, all security robots share others. We don't rewrite features from scratch. So that will bring us to the next concept.
Here you have defined the battery level to be private, right? So in
Yeah.
this case, how can this be accessed meaningfully from outside the class?
See, battery level is private, as in only the functions within the class can access it. So let's say now over here, what I've done is I've just console logged whatever is my battery level. So from outside, I can call this particular function and it will show me what my battery level is. But from here, from outside, I can't do something like R1 dot, let's say battery level. This is not allowed. Since it is private, this is not allowed. So it will say battery level is private and only accessible within class robot. So this from outside, I can't directly access my battery level, but I can access any function like show status or show battery level, any function within this class and access the battery level variable. Yeah,
When would it make sense to keep something as private and something as public?
sure. So let's say I want some variables which I want to hide it from the world actually. So in this case, battery level, let's say I don't want this particular variable to be open to the public. So that if let's say I make this variable open to the public, anyone can actually manipulate this variable. They can assign some other numbers or they can manipulate it in any way. So in that case, it will create issues for the robot. So in this case, I have kept this variable as private and only using the functions which I have exposed with public, only those using those you can access that particular variable. So in those cases, when you want to prevent any outside person from accessing or manipulating a particular variable, in that case, it is best to use private.
Okay.
Yeah. Yeah. So let's move ahead. So now, like I said, many robots share some similarities. So each time creating a separate class for each robot will be cumbersome. So what can we do? So in TypeScript, there is a concept known as inheritance. So what is inheritance? Inheritance lets us create a general robot family and then specialize it. So let's say I have a security robot. So let me create a class for it. Class, let's say security robot. Now, security robot is also of type robot. So now I don't want to redefine the name, the battery level, all those variables. I don't want to redefine, but I want to only define qualities that are specific to security robot. So what I can do is I can extend from or inherit from the base class that is robot. Yeah. Then I will define only the functions which are unique to the security robot. That is the petrol function. Let's say console.log. This mm, uh, this dot name is petroleum using this dot serial number. Yeah, let's define a security robot now. Constant security is equal to new security robot. Let's call him Sentinel and let's pass a serial number. Yeah, let's pass this. Let's call dot show status, which is from the base class, and let's call petrol, which is specific to the security robot class. Yeah, let's see. Uh, so the TS Yes. So as we can see, it says, hello, I'm Sentinel, and my battery level is 100%. So this is from this show status function, which is from the base class that is robot. And this function, sorry, I made a mistake over here. Yeah. So over here, then specific to this security robot class, this petrol function console logs this particular console. So it says Sentinel is patrolling using serial number this SR01. So this is inheritance in TypeScript.
Nandan, let's say if here in this code, if the
Hmm.
security robot did not extend robot, like that's what you're doing in inheritance, right?
Yeah.
What exact duplication would you immediately have to do to rewrite it?
Yeah. So see, if it didn't extend robot, what I would have to do is see I would have to write a show status function. I would have to rewrite this. So whereas this show status, then I would have to rewrite all these public name, battery level, the serial number, this constructor, everything I would have to rewrite. But so that is actually repetition of code, which I'm trying to avoid. So what I can do is I can just extend from the robot base class and I get all these functions. So all these qualities that are name, battery level, all this, and whatever is specific to this particular security robot. So that is the petrol function.
So at scale, this helps in keeping things consistent when you have to
Correct,
scale systems.
correct. In scalable system, we don't have to, using this inheritance method, we avoid code repetition.
Mm.
So we can reuse any piece of code with this.
Okay.
Yeah. Yes. So let's move to the next concept. So next concept is abstract classes. So abstract classes are mandatory robot contracts. Abstract classes define rules that all child robots must follow. So let's define an abstract class. Abstract class, let's say lab robot. Abstract of task. This will be a void function. Then I have my diagnostic, which will just So, diagnostics. Let's say class cleaning robot extends this lab robot. Yeah, and I will do this. Perform task is this. Let me create a cleaning robot now. C1 is equal to um, cleaning robot. I will call C1 dot diagnostic, and I will call C1 dot perform task. Let's run it. Yeah. So what I've done here is I've defined an abstract class called lab robot, which has to do certain things. So that is, it will do this perform task and it will do the diagnostic. Uh, so here in my abstract class, I take the perform task, whatever it is, to that specific robot, and each robot has to do this diagnostics before it does this task. So as you can see over here, I'm doing the diagnostics. So it says running diagnostics. And once that is done, then it says cleaning in progress. So this C1 dot perform task. So this is abstract class basically. So this is kind of the rules that each robot has to follow.
Let's say if a developer forgets implementing the forget task,
Hmm.
sorry, the perform task,
Yeah,
what kind of error would we encounter?
sure. Let's try that. So let's say I've defined my class cleaning robot, extends the lab robot, but I've not defined my perform task. So let's try this. I'll do that. Yes, see. See, it will throw this error. Non-abstract class cleaning robot does not implement inherited abstract member perform task. So it will give you this error saying that you have missed to perform to specify this perform task function. So each robot that you define that inherits from this lab robot should have the perform task method. Otherwise, the TypeScript will throw this error saying that it does not implement the inherited abstract member perform task.
So typically it's affecting the entire workflow.
Yeah. See, each robot will have a set of rules, and so those to follow those rules, we make use of abstract classes.
Mm.
So now if I add this perform task and run this code again, yeah. So now it works.